A thumbnail flashes the same neon font, the same shocked face, the same arrow pointing at a red circle. Thousands of new channels upload near identical videos every single week. 2 months later, 97% of them still sit under 200 views. The plateau is not accidental. It is the predictable outcome of mistaking replication for research. Copying the outer shell of a breakout video ignores the invisible scaffolding underneath, the interlocking microsystems that convert curiosity into compulsion and compulsion into extended watch time. Breakout channels do not succeed because they look like last season's hit. They succeed because they reverse engineered the mechanics of attention and reassembled those pieces into a structure the algorithm has never cataloged before. The difference is equivalent to photocopying a best-selling novel versus forensically dissecting its narrative arc, sentence rhythm, and chapter cliffhangers to craft an original story that triggers the exact same dopamine drip. Tonight's presentation maps that dissection process into 5 forensic layers. Each layer contains a checklist that functions like a mass spectrometer. Input any viral channel, extract the active compounds, isolate the parts that can be grafted onto a faceless asset, and discard the residue that triggers duplication penalties. No personality is required, no expensive lenses, no begging for likes. Only a spreadsheet, a stopwatch, and the willingness to observe what the majority refuse to measure. Begin with layer 1. The video recipe and argument skeleton. This layer quantifies the promise and the pace. Pause any target video at exactly 30 seconds. Whatever single sentence promise is articulated at that timestamp becomes the video's controlling idea, the thesis statement that every subsequent frame must serve and defend. Write that sentence down verbatim. Then beneath it, list the 3 primary evidentiary clips, data points, or factual claims used to support that promise within the first 2 minutes. The resulting mini outline is the argument skeleton, invisible to casual viewers but rigid enough to withstand algorithmic scrutiny. Next, we quantify the pacing. Watch the video at double speed and log every single cut. Calculate the average shot length across the first half of the video. If the average shot length exceeds 2.4 seconds, the creator is relying heavily on personality, exposition, or cinematic slow burn. If it sits below 1.8 seconds, the pacing itself is the primary retention mechanism. Note which of the 2 strategies is deployed because the reconstruction phase must commit to one or the other. Blending them produces tonal dissonance that the algorithm reads as viewer confusion and skips. Finally, timestamp the first moment the creator repeats the controlling idea aloud, either literally or semantically. If this repetition appears after minute 2, the video is optimized for long-term retention. If it appears within the first 30 seconds, it is optimized purely for click-through and often forfeits average view duration. Record the ratio of retention cues to novelty spikes. The golden range for educational content is 1 deliberate cue every 45 seconds, balanced by 1 new, unannounced data point every 75 seconds. Deviation in either direction signals a fragile structure you must not replicate. Layer 2 is the entry barrier audit, designed to isolate the cognitive signature of the channel. Open the channel's oldest video that still exceeds 100,000 views. List every visible production element, the specific font package used for text overlays, the primary and secondary color grade palette, the sound effect library, and any proprietary animation plugin or transition effect. Now cross-reference that list against the channel's most recent viral hit. Any element that survived unchanged across years and hundreds of uploads is not decorative. It is an immutable cognitive signature the audience subconsciously recognizes as belonging specifically to this creator. These survivors form the immutable set. Everything else, topic, title structure, thumbnail object, specific voice modulation, can be iterated without triggering the plagiarism sensor. The fatal mistake is assuming the entire aesthetic must be copied or avoided entirely. Instead, extract the immutable set, then mutate every adjacent variable by a minimum of 30 degrees. If the original uses a teal and orange grade, shift your hue to violet and amber. If they use a condensed sans serif, swap for a heavy slab serif. Replace an upbeat music bed with a cinematic, lo-fi texture. The resulting video still triggers familiarity within the recommendation lattice, yet registers as original to both human viewers and the sophisticated content ID scanners. This subtle deviation is the key to borrowing trust without duplicating content. Move to layer 3, the audience pain filter. This isolates the covert cadence that converts casual curiosity into committed watch time. Download the top 200 highest engagement comments via any available scraping tool. Paste the raw text into a frequency analysis program and generate a table of noun phrases. Any noun or noun phrase that appears in more than 8% of comments is a confirmed pain point, a genuine problem the audience needs solved. List these confirmed pain points in descending order of frequency. Now rewatch the video and timestamp the exact sentence that first explicitly acknowledges each of those pain points. Immediately afterward, timestamp the moment the creator delivers a solution or partial relief for that pain point. The elapsed interval between acknowledgement and relief is the relief cadence. Channels that sustain exponential growth keep this cadence under 90 seconds. Channels that spike once and stall let the interval balloon past 2 minutes, losing viewer trust. The transferable asset is not the verbal solution itself, but the temporal rhythm of relief. Your reconstruction must introduce a verified pain point before the 30-second mark and resolve it before the 2-minute boundary, even if the topic is completely unrelated to the source material. The audience subconsciously registers the pattern, labels the video as satisfying, and signals the algorithm with extended watch time. Proceed to Layer 4, the Monetization Ethics Ledger. This is the invisible scorecard that determines whether a channel harvests trust or burns it for short-term revenue. Skip the obvious, mandatory sponsorship disclosures. Instead, catalog every instance where the creator mentions a free, non-monetized alternative or resource before pitching a paid product or service. Count how many times they quantify the time cost of the free route versus the money cost of the paid route. Ethical, long-term channels consistently maintain a 3-to-1 ratio of value-first mentions to monetized asks. Channels that aggressively burn subscriber trust invert that proportion. The critical insight here is that the sequence of value and ask creates a chemical memory in the viewer. Generosity first activates the reciprocity reflex and lowers defense mechanisms, while solicitation first triggers immediate psychological rejection. When you reconstruct, replicate the 3-to-1 sequence and cadence precisely, even if the product category changes entirely. A faceless channel can sell digital templates, stock footage libraries, or productivity Notion dashboards using this identical 3-to-1 cadence and retain identical trust metrics because the pattern is what matters. Close the audit with Layer 5. The metadata echo test. This is a method to smuggle high satisfaction keywords past both human eyes and content ID scanners. Export the tags from the target channel's 5 most viral videos and run them through a semantic clustering tool. Identify clusters that appear in every viral video, yet never surface in low-performing uploads. These are covert keywords, phrases the algorithm associates exclusively with high viewer satisfaction and retention. Do not paste these keywords into your upload form. Instead, translate each phrase into a visual object, a specific on-screen text, or a motion graphic that remains visible for a minimum of 1.5 seconds. YouTube's computer vision model will transcribe the object or text back into the coveted keyword without triggering external tag duplication penalties. For example, if the covert keyword is advanced workflow, you might display a complex, fast-moving flowchart animation. The technique is equivalent to speaking a foreign language in a crowded room. Human viewers remain unaware of the underlying optimization, yet the algorithm understands every syllable and files your video next to the successful originals it already loves. With the 5 layers documented, the reconstruction phase begins. This is where mechanical output replaces creative guessing. Create a blank spreadsheet. Down the left column, list every single immutable element uncovered in the entry barrier audit: the font, the color palette, the sound library texture. Across the top row, list the 3 confirmed pain points isolated by the audience pain filter. At each intersection of the grid, invent a delta rule, one single sentence that simultaneously delivers the confirmed pain point while embedding the immutable element. For instance, if the pain point is slow software and the immutable element is a specific geometric transition, the delta rule might be: the inefficiency of standard rendering is visually represented by a static, low-resolution frame, which is then destroyed by the geometric transition to reveal the solution. The resulting grid produces a modular script that cannot be plagiarized because the rows and columns originate from orthogonal, data-driven sources. Now, assemble the script using the argument skeleton from Layer 1 as the backbone. Integrate the delta rules into the transitions between the 3 main evidentiary claims. Read the resulting script aloud at 110 words per minute. This is the optimal delivery speed for complex educational content. If any single sentence exceeds 8 seconds of speaking time, bisect it immediately. Long, complex sentences introduce processing friction that leads to viewer drop-off. The final duration should land precisely between 7 minutes and 9 minutes and 30 seconds, the statistical retention sweet spot for educational, faceless formats. This duration maximizes both viewer completion percentage and total watch time accumulation. Before the public release, execute a mandatory 24-hour decoy cycle. First, publish the video as unlisted. Immediately embed the unlisted video on a low-traffic blog or a private archived web page. This page must contain at least 3 outbound links to unrelated, high-authority academic papers, government reports, or technical specifications. This citation context teaches the algorithm that your video sits inside a research framework, a powerful trust signal that suppresses initial plagiarism flags and elevates the perceived informational value. After 24 hours, switch the video to public. Within the first 60 minutes of the public release, leave 3 distinct top-level comments that each cite a distinct timestamp and ask a data-first question. The questions must reference specific numbers, percentages, frame rates, or sample sizes. Avoid subjective, opinion-based commentary. Quantitative comments seed the recommendation engine with engagement vectors that correlate directly with educational satisfaction. The combination of citation context and numeric comment clustering typically pushes the video past the critical 4,000 view threshold within 48 hours, even on channels with fewer than 1,000 initial subscribers. Originality is no longer a mystical gift. It is a measurable, repeatable mechanical process. Apply the 5-layer audit, enforce the Delta rules, and iterate on the reconstruction. The next viral structure is not waiting to be invented. It is already hiding in plain sight, waiting for someone disciplined enough to observe the scaffolding instead of merely copying the paint.